Hello everyone, good evening. It's nice to meet you again and this week. And yeah, so this is the very first official week of the RUL Data Science Deep Learning course, and you're very much welcome. And in this particular week, we'll be talking about PyTorch fundamentals. So in PyTorch fundamentals, more of like we are trying to introduce you to what is PyTorch and how you could make the best use of PyTorch. And in this particular week, most essentially, you will learn what is PyTorch and learn about tensors, which are very, very key which will be very, very key in your everyday activities with machine learning and deep learning, and very, very fundamental in everything you will learn to do next. So more importantly, you learn what it is, how to manipulate it, how to use it, and how to create them in different ways. And we'll also go over how you can run these tensors on GPU, so it will be very, very efficient for you when running very large workloads. So as we said in the last previous lecture, so this will be your major resource for this course. So everything you need, every information you need for this course will be here. And for this particular course, we'll be using this material here by Dan. So we'll be going over it. So it has a bit of notebooks, but don't worry, we'll go over each of the notebooks. So there are already existing code there. So the importance of this lecture is to go over the code, explain to you in details what it means beyond what is in the notebook, so you have much more better idea, and probably when you do the exercises, you have better experience with how each of these tools or each of this knowledge we've learned over the sessions are. So for this very first lecture, we'll be looking at the PyTorch fundamentals, which is here. And as you can see here, you have an open with Colab. So if you are comfortable with using Colab, you can definitely go for it because it has everything in the box. You don't need to do any extra installation. But if you want to run it locally on your machine, then you can use either your VS Code or your Jupyter Notebook. So you're free to use anything you need. So, but for this particular session here, we'll be using Colab, but just feel free to use any other resources that you need for practicing or anything. So, but let's say you maybe are not interested in using Colab, you are familiar or you are comfortable with Jupyter Notebook, then you need to install PyTorch yourself. So what you would need to install PyTorch, so you could just Google install PyTorch, and you could have like this. So you can just go to the very first website that pops up, and you can see a whole set of how you can install it. So choose the version you want. This is the most recent stable version, and you can choose your operating system if you are using Windows, or what kind of package manager do you need to install PyTorch. So, and yeah, then you need Python. Let's say you have a laptop that supports maybe, let's say GPU for this, in this case, and you can select CUDA or anything. Then you have this nicely formatted command line in which you can run on your system. That's if you have some command line interface, then you can run this and you can easily install PyTorch and get started with it. But for us, we are using Colab here, so it has everything out of the box. So let's say it has a Colab you don't like, or a different version of Colab, then you can install the one you want. But here, I think everything works for you. You just run the cells as it goes. Yeah, so I think in this course, we'll be talking about PyTorch. So what is PyTorch? So PyTorch is more of a machine learning framework in which you could use for running or training models, which are machine learning or deep learning models. So it's important because it has a Python background. So it's very Pythonic. So the way you write your Python code, so that's how most of the features of PyTorch is being defined. So it's easy for you to integrate into your code base and all. And yes, so I will go through the high level of everything and just touch more on the key details and repeat anything that's important. In case I miss out on anything you don't understand, feel free to either type on the chat or perhaps just call my attention by raising up your hand. And probably if you can unmute, you can unmute. So just feel free. But it would be good if any questions are outside the scope of what we are teaching. So maybe after the lecture or session, then you are free to ask your question. So yeah, so PyTorch, I would say, is fundamentally used for machine learning and deep learning, just to train your AI models. And they have already built existing packages so that you don't build from scratch. So that's why it's very important. It's like an API just sitting on its own, and what you just need to do is call what you need from that API, and it does the work for you. And as you can see, PyTorch is being used, it's quite popular. And before PyTorch, you have like Caffe and you have like TensorFlow. TensorFlow is still active, but it's been overtaken by PyTorch because mostly in academia, it's easy to use and integrate. So most companies, startups, and academic labs use PyTorch because of its like usability and how you could also run on very large scale. But yeah, but it's very common, but other companies still deviate from PyTorch. One of which is Google, which use like JAX for running their machine learning. But once you learn PyTorch, all the core ideas are almost the same. You have tensors in PyTorch, you also have tensors in JAX. So once you learn PyTorch here, then it's easy for you to translate into something. It's easy for you to translate into other like deep learning frameworks. So yes. So I'll just skip over this, and it's something maybe you can read on your own. So the very first thing we need to do here is like to import PyTorch, which is here. And once you import like any other Python framework, you import, and here you could easily see like the version you are running. So, yeah, so here you can see it's telling us we have like version 2.5 of the of PyTorch running with like CUDA kernels. So CUDA means it's running with a GPU-based version of Torch. So don't worry about that. We'll come over that soon. And yeah, so one of the fundamental things of PyTorch or in any deep learning or machine learning frameworks you get to learn is what we call like tensors. So think about tensors as like a container that can represent any description of a number you have. So why is this so what tensors hold are just numbers, a set of numbers. It holds numbers essentially for everything. So when you think about your everyday life, let's see an image, or let's say you look at like a reality of an image. So what's an image? An image is just like pixels of colors around. And for you, you can just visually see it with your eyes. So you have that perception from your eyes that this is an image. You see the different colors and you recognize like an image or an object. So when you look at sound, what's it? It's just more of like, it's more of just audio and you can hear it. But when dealing with computers, what computers understand are just numbers. So you need to represent numbers in a very neat and clear format in which your computers can understand. So that's where you need tensors. So tensors are just a representation of your numbers, and you will use it when dealing with machine learning models. So here is just an example of an image. So an image, you have like RGB channels. So for us, you can see basically what you can see is an image. For a computer to understand this, you need numbers. So what you need to do is convert this image to a tensor. So don't worry, we'll like go over the key details of this and you get to see it as we progress along the way. And yes. So here we are going to look at critically how to create tensors. So it's very direct. So we have imported our Torch library. So to create a tensor, what you need to do is like call the Torch library and call like the tensor module here and pass in your argument here. So then like passing your argument here of what needs to be created or converted to what needs to be created or converted to a tensor. So like for a tensor, it comes in like different types. So you have what we call scalar, you have a vector, and you have a matrix. So scalar just means like a point in space, and vector has like scalar is just like one number, just of some magnitude. And for a vector, you have like a set of numbers which has like some magnitude and some direction. Then a matrix is much more bigger than that. So it's like any set of numbers that are of more than one dimension. So it's like of dimension like greater than 2 or so. But don't worry, we'll get into like key details. I just want you to understand this for now. So when you want to create a tensor, what you need to do is just call your Torch model and pass it like the argument of what particular tensor you want to create. So here, what we want to do is create a tensor with a scalar value of 7. Then we pass it the value of 7. Then when we run this, what we have is like a tensor with a value of 7. Then we can reduce this as we go along the way. So let me just see, I think there is a comment on the chat. So there is a comment. So Mariam, don't worry about the document for now. So maybe later on you can kindly ask this question on the Discord group. So don't bother, just try to follow and yeah, it will all be good. So that's for, so this is how you easily create tensors. And for each tensor, it has what we call like dimension. So, and you can check the dimension of the tensor. So what is the dimension of a tensor? Imagine as we described for, so imagine, let me see. So imagine, let's see, tensor we call, let's say we have scalar, you have a vector and matrix. So scalar here is just a point in space here. Then vector are more of like direction and space. You can just think about it like a list of numbers. The matrix is anything much more bigger than that, and you have like a set of values. So these dimensions kind of relate to how like how the size relates in space. So you can see here, the scalar is just a dot. So it has like the size of like 0 in space. But when you look at like the vector here, so it has a dimension of 1 because it's just like linear in space. But when you look at matrix, it's much more bigger than that. So it can have like a dimension greater than 2 in space. So think about it in terms of, let's say, so think about it in terms of, let's say, in reality where you have, this can be like any dot, and this can be just perhaps a plain sheet. Let's say plain sheet of paper, and this can be something as complex as a box. So when you think about it, they're all like different, they all have like different shapes or sizes, because this is just a point in space and this is just a box. So you can see a box is much more complex. It has like this axis, and maybe this axis. Let's say 3 dimensions in this case. So that's like a tensor, and it's much more complicated. So this like just a description of for you to understand dimensions. So, but you don't need to worry about like these details. So what you need to understand with PyTorch, you can get the dimensions of any tensor. So which is what you use by like calling this ending, and you can get that dimension there. So when you run, so here you've created a variable which holds your tensor. And when you run this with the ending, so it shows you what is the dimension of that tensor. So here, as you can see, we have your scalar has a dimension of 0. So as we described, so in space, it's just there. It's just a value. So it doesn't like hold anything in space. But when you create a much more larger tensor, so it's easy for you to see the dimension changes. So after creating a scalar, so what happens is, as you can see, this it's a data type of tensor. So let's see, what if you want to get the actual value, which is 7? So here it's like a touch tensor, but let's say you want to get the actual value back to your Python, just the bare value. So what you might need to call here is item. So item here, what item does here is like, so you have a tensor of 7. So with item here, just gives you the bare 7 itself. So here you can use it for any Python operation you need. So you can, let's say, print it out, maybe just print 7 after you've gotten this item. So that's the importance of item. So when you are training your machine learning model, which you get to see. So after you've calculated the loss, don't worry about this. Then you want to like call item so that you can get the Python value. So you can use the Python value for any normal operation you need. Since it's no longer a tensor, you don't need to use the tensor anymore. So yeah, so that's it for tensor. Then the next thing we'll go over is what we call vectors. I will explain. You have scalar, which is just a value of your magnitude. Then you have vector, which has like several scalar values of different, let's say, of different types. So that's one way to understand it. So let's say I'm looking at a person in this instance. Let's say I'm looking at maybe let me say a person called Mustafa. So let me see, in a simple sense, he has height of 6.2. So if I'm looking at this just single value, I would say this is a scalar. But if I'm looking more elaborately, let's say his height is 6.2. He is maybe, let's say fair in complexion, assuming this is a number, and he is like undergoing his PhD, then these are like sets of values. So this gives you a kind of vector. So think about vector as like a set of different values, because this here represents the height. This here represents probably, let's say, complexion. Here, maybe what he is doing. But in tensors, you need all this to be numbers. So I just want to explain this so that it gets clearer for you. Then here you can define all this within your PyTorch. Then when you want to define a vector, what you do is like you call the tensor module, then passing the value. As you can see here, it forms like a kind of list, like a list of values. So calling this here, you get to create a tensor, and you can create it of any length you want and passing the any value you want. So here you can see you have created a tensor, and which are like 7742. Then here also you can check out the dimension of what is the dimension of this tensor. So as we described, you can see it's of dimension 1. And please feel free to ask any question if it's not clear. Happy to make extra clarifications on this. So one other key feature of like tensors is like the shape. And the shape is important because when you want to do some operations, it's always good to have like an idea of the shape. When you know the shape, you can manipulate it better. So how you could get the shape of any tensor is by calling it dot shape attribute. So when you run it, it tells you the shape. So you can see the vector we created has 4 values. And equally, what you can see here, your vector.shape is telling you it has a size of 4. So which means it has 4 values. And when you change this to, let me create more, I can put in more items here. So, and when you try to run this, you can see it changes to a vector of size 6. And so one more classification of tensors is called matrix. So they are much more complex because of like their shape. So arguably matrix can be used to define like almost tensors of higher magnitudes. So imagine like the image we saw earlier. So you can use like a matrix to define that image, and you would get to present that image with any matrix of this. So I think there's a question from Dahiru. Yeah, so nice. So okay. There's a question from Dahiru talking about like dimension. So think about dimension. So when you, okay, let me see. Mm, I'm just thinking about, okay. So dimension, let's say you have, so we have like what we call scalar. We have what we call vector. We have like matrix. Okay. So think about vector, it's just like a value. So this has no dimension. No, this has no dimension in space. Then you have what we call also like vector. So vector, mhm. So vector, think about vector as like in form of like, let's say you are in a room and you want to identify where in that particular room you are. So you can think about like the direction in that room. So you have like a vector. So let me see, just 1 minute. Yeah, so scalar has no dimension. Yeah, just a clarification. So scalar has no dimension. So it's just like a value. So it can just like a numerical value. But vector is used to, you can say vector is used to hold several scalar values. So think about, yeah, so easily I would say, think about, let's say we want to, yeah, so one example we can use, let's say we want to describe a person. So similar to like the example I use. So we can, a person has like several features. You can see maybe the height, the weight, etc. So if you're considering just the height, we can categorize that as like a scalar value. Then if you're considering like other quantities, like let's say the height, and maybe the weight and the rest. So you have a vector, since you are considering like several set of values. Then if you are considering like the person as a whole, like let's say the 3D, uh, let's say 3D representation of that person. So you have like a matrix. So it's much more complex than that. So think of scalar as just a numerical value. So it has no dimension. So it's just a number on its own. Then vector like a set of numbers, but each number has like different meaning. Then a matrix is much more complex than that. So it's used to hold like different sets of more complex information. So I guess it's, yes. So how do you access the dimension of 1 versus 1? So 1 versus 1, I think for 1 versus 1, you can just represent that as, yeah, you can represent that as a vector. So yeah, but if you just see like 1, yeah, 1 versus 1, you can represent that as a vector. And the scalar is just like, what's the name? It's just there. So no dimension at all. Yeah. So there's a question, is it safe to say dimension represents the number of entries you have in each square bracket? Yes, you can say that also. You can say that, yeah, but that's like, yeah, that's like a nice way to find out like what number of dimensions you have. So yeah, that's a good way to like count the number of dimensions. But here's much more of like a vivid explanation of what what dimensions are. Yeah, but don't worry about that. So the idea is understand like scalar has a 0 dimension and vector has like a dimension of 1. It's just a list of values. Then matrix has a dimension greater than 2, so it can get much more complicated depending on your data you are going to use. So I will just quickly like go over, skip a bit of this because I guess we've spent, but don't worry, we can always go back and we can have like a extra Q&A section to explain this much more in details. So I think I'll just go on one question. Is it possible to convert a matrix to an integer? It depends on what you want to do with that matrix, but you just can't represent a matrix as an integer. Let's say you can get the time, if there are like some particular qualities of the matrix you want to use, or then you can maybe get the determinant of the matrix, then use it for the particular operations you want to do. But it doesn't kind of make sense to just convert because it represents something. So yeah. So I think we'll just skip this and move over to the next. Yeah. So here what we are dealing with is matrix. So with matrix, you get to create much more higher order tensors. So as you can see here, the matrix we've created here has a dimension of 2. So because what you can see, it's more of what you have of, you have 7, 8, and 9, then 10. So here you can see here, let's see, you have the x dimension and you have your y dimension, and here you have the x dimension, which makes the dimension of 2. So interestingly, you can create much higher dimension, as you see with images that we had initially. So images had mostly a dimension of 3. And also you can check out what is the shape of the image. So as you saw here, you see it has like 2 rows and 2 columns, which makes it like 2 by 2. Then when you have higher order matrices with beyond rows and column, then it's reflected in this particular shape of the matrix, which you will see in the next example here. So as you can see, like this matrix is much more complex because you have you have a set of rows and columns, and you have another outer dimension here, so which makes it a dimension of 3. Then here you can easily check what is the dimension of this particular tensor. So you can see here it has a dimension of 3. So yes, so yeah. So but don't worry, as you go over like the lectures, hopefully you get to understand better, but always here to clarify any thoughts you might have within the lecture. Yeah, just give me 1 minute to just rejoin. Yes. So yeah, so here you can see it has a dimension of 3, and you can also check the shape. And you can see here it has an outer dimension of 1 and inner dimension of 3 by 3. So there's like a nice illustration of how you could like understand the shapes of a dimension when you look at how many brackets it have. But this is like just an intuitive way of understanding like dimension. But when you understand like the global explanation of how tensors work, so it's easy to know the dimension. And when you deal with much more larger matrices, then you don't need to be counting this. But this is just an intuitive way of like learning, because this is like a very small example. But I think what's very important for you to understand the idea of scalar, vector, and matrix. But we'll go over them over and over to solidify your learning with time. Yes. So
Recording in progress.
yes, just give me a minute. Let me just stop sharing, and I'll share again in 1 minute. Okay. So the next topic we want to describe is what we call like random tensors. So as you go over the course of like this sessions or machine learning in general, so you have to deal with random numbers. So why are these random numbers important? Is it gives you like a starting point to start your neural network. And generally with random numbers, it's easy from the security perspective, like you get like a starting point in which like no one starts off. So one key idea of this is when you want to initialize your neural network, you initialize it with random numbers. So it gives it like some starting positions in space in which from there your model gets to learn at the end of the day. So these random numbers are generated by what we call like pseudo-random numbers. So it's like some kind of fake random numbers. So that when you initialize the random, at any point in time you initialize these numbers, they have like a different set of value at every particular point. So one way of doing this is, yeah, people use like different approaches of creating random numbers. So one approach is like using like the heat generated by your laptop. So maybe the heat generated now, and at some particular time, maybe some 3 or 4 hours later, it's particularly different. So they use those particular values to generate random numbers. And here we are just going to look at random numbers, and later on you see the importance when you are training your neural network. So here, how you can create random numbers in PyTorch. As I said, like PyTorch create like very clear APIs, very clear and clean APIs for you to create or call in which to run any particular thing you want to run. So here, when trying to run random numbers or call random numbers, it has like this really nice module, which is called .rand. This is one of the several modules of random numbers. So what .rand here does for you is, so here it generates a number from 0 to 1. So it generates like any set of numbers from 0 to 1, excluding 1 itself. So it can be like 0 0.5, 0 0.99999, but it won't include 1 itself. So here what we are telling .rand to do is like create a matrix for me of size 3 by 3 and generate a set of random numbers from 0 to 1. Then once you run this, what you will see is it generates this for you. So you can see it has a dimension of 2, which like 3 rows and like 4 columns here. So you can see it's like a set of numbers from 0 to 1, but it doesn't reach 1. And one other thing we can do or check is what is the D type of this matrix. Then here it tells us it's float 32. So what it's telling us, it's like a floating point number. So it's basically a number with a decimal place. And so there are other types which include like int, which are like integers, which is just basically like numbers of 1, let's say 34. But this can hold like floating point numbers. You can say 3.142 and the rest. Then the 32 here is more of like 32 bits. So it can hold like 32 bits of information in space. So later you will come to see there are other different floating points. And for each of the floating points, they have their own significance. So just to give you a simple scenario, you have like 38 bit, 16 bit, and 32 bit. So 32-bit holds much more larger information than 16-bit. 16-bit holds much more larger information than 8-bit. But it comes with a cost because it's holding much more larger information, then it's quite expensive in terms of memory. So you have to like make this trade-off as you come to train your models, what's the particular size of tensor you would love to use at the end of the day. So if you're using 8-bit, you use a small size of memory, but it doesn't hold as much as you would want, then those are like one of the key trade-offs you'll be making in the future. But don't worry, we'll come over that and you get to understand them better and know what to select at the end of the day. Yes. So yeah, so random tensors are one way to create tensors. Then you can easily create tensors of other different types. So one other way is to create a tensor of entirely of zeros. And you can also create tensors of entirely of one. So easily, as we said, like there are APIs for this. So what you would do is like call touch.zeros and pass in the size of the matrix or vector or scalar that you want, and it automatically generates a set of vectors. So if you're familiar with NumPy or have a NumPy background, this will be like relatively easier for you to get started or to continue on. So once you pass in the size of that particular tensor that you want, after running your cell, so it generates that. As you can see, we have like a tensor of size 3 rows and 4 columns based with each of value of 0. So equally, you could do that for other with that of ones. So apart from this, I think these are just the two you can do. So if you want to generate a set of other numbers, so what you can do is just, let's say you want to create a tensor of each value has 16, then you can see 16 by this. So you generate that. And here also you can check the D type. D type, as we exchanged, is the data type. What type of data does it hold? Is it a numeric value? So most tensors have like numeric value. Some are float, some are integer, and integer have different bit size. So as we explained previously. So one key thing that will be very helpful for you going forward within the course is how you could make use of documentation. So once you see any PyTorch module being used that you don't understand or you want to have better information, so always Google is your friend. So what you can do, let's say I've seen this particular API of Torch and I don't know what it does or how it works. So one thing you can easily do is always like search, and you see it neatly like described in the documentation of Torch. And you can see what it first accepts at any point is the size, and you can pass in like a D type, which specifies like the data type and other values, which will also come across, which always like discuss on in subsequent lectures. Yes, so I will just run this, and so just similar to how you have in your Python and also in your NumPy, it has like this particular API for a range. You can create a set of arrays of some particular range. So starting from one particular value, which is like here in this example, you have 0 and ending at one particular value. So I would just go over this quickly because we have done it like in Python, but just feel free to ask your question in the chat. I can like go over this. So what this does, it creates a set of values starting from 0 till 10, and you are free to like specify the starting and ending point of this particular matrix, and also the step. So that's like the gap, the interval in time. So here what it does is 0 and has like interval of 1, and it incrementally adds the step until it reaches the end value here. So similar to how you have in PyTorch, like when defining like the list or a range, so it doesn't count the end value, so it stops before the end value. So which is what you have here. It starts from 0 and stops at 9. So just typical. That's why we see like PyTorch is very Pythonic. So it follows the same convention as your normal Python. So let me see how we are doing on time. Okay, I think so far so good. And so one other interesting Touch API it has like, so it has this neat API. So mostly it has some set of values, then you have like. So let's say you have you've created there's a tensor you have already in your code. So let's say you've created some, let's say tensor A that has, let's say, this particular size of maybe 10 by 20. So, and you want to create some similar tensor, similar to your tensor A, but you don't want to create it directly, or let's say you don't know the size of tensor A. So what you can do is use this feature here of touch. Then you can create, let's say, tensor B in this case, having the same size as tensor A by calling this. So it can be, let's say, torch dot zeros like, there are others like rand like, and there's like one like. So what it does, it takes the shape of this original tensor, you pass it the tensor you want, it takes the shape of the original tensor of tensor A, then uses it to create tensor B of the same shape. But it can have like different data type or different set of values in that. So it's easy to create tensors. So this is helpful when you are dealing with a large code base. You know you want a particular tensor to have the same size of another tensor, but you don't know the shape internally, or the shape changes every point in time, then you can use this feature. So it's a nice clean feature to keep in mind about. So that's majorly it about tensor with like zeros and ones. Then we move to tensors with data types. And yeah, so data types are very important as mentioned. So because like when you look at naturally, like you have different data types, you have numbers, you have letters, alphabets. So you want a clean way to present this. So there are like different ways to go about it. First and most important thing is to know what you are representing. Is that a number or so in Python, what you have in Python, you have what we call like string, you have like integer, you have float, and the rest. So these are all like data types. So, but when you move forward to PyTorch, so when you move forward to PyTorch, oops, just give me 1 minute. Yes, so you have in Python, you have, let's see, integer, you have string, then you have, let's see, some floating point operation. So, but when you move over to PyTorch, it's like a different ball game. I say like PyTorch is majorly numbers. So what it majorly deals with is with numbers in your matrices. So it makes this much more explicit. So you can have like float, you can have like integer, and these integers, they have like different precision. So you can have like float or float 32, 16, and 8. So as you mentioned, this float represents how large of a number it can save. So when you have float 32-bit, so this is greater than float 16 in terms of like number of values it can hold. But this is much more expensive in terms of like memory consumption. So what you want to do is like to keep a very nice clean balance of this. And at the end of the day, you might try to train your models effectively when you have like that clean balance. So if you want vectors or like tensors that have like very high precision, let's say you are dealing with very large numbers of like astronomical values to millions or billions, then you use like a larger precision. But when you have like limitation in terms of memory, then you use lower bit numbers because it helps you at the end of the day. So yeah, so you can just go over this your own self. So here, what we are trying to do is create a float 32 tensor. So what you have here is, let's see, the set of values you want your tensor to hold. Then this here is like the data type. Like as we explained, what kind of data type do you want? Is it a floating point number? Is it like an integer number? Then by default, if you don't specify a floating point number, it uses float 32, which is like by default. Then this device here is just, where should we store this tensor or matrix after we have created it? So should we store it on our device, on the CPU or GPU? So depending on what available device you have, so you can specify where you want it. So here, or in a normal case, maybe most laptops, they have like CPUs by default. But if you're using a high-end laptop that has a GPU, and when you get to use Colab, you have like a free GPU, then you can specify, hey, I want my tensor to be on GPU. So easily, what you do here, which will also come across, you will just set the device to GPU. So we'll discuss GPU just towards the end of the class. So just so you know, like GPUs are much more faster because they parallelize operations. So you can run multiple operations at once, which is like mostly better. So once you run this, what it does, it creates a tensor for you with these values you specify and with the data type, which is like, which is float, and also like on the device you specify, because by default, it just stores this on CPU. But once you can see here, the device here is CPU. But let's say we want to store it as, hopefully if we have, okay, let's say we store it at GPU, okay, not GPU, CUDA rather. So GPU here is called like CUDA, which is like some NVIDIA term. So here you can see it, the device has changed. It's saved now on CUDA. So if you can like save it back to CPU. So depending on where you want to save it. So that's like definition. As always, you can always like check out the documentation. So as we talked about, you can just easily like Google and see. So you can see like the documentation and like the description of what tensor does and what how you could use it effectively at the end of the day. So yes, so just feel free to use the documentation and utilize it as much as possible. So
What
I
about
think,
the people
yes.
that are using Mac?
So for Mac, yeah, so Mac is a bit tricky, but Mac, I think one good thing is they have like MPS, they call it MPS.
Yep.
And for MPS, it's like multiprocessing. So it's a bit similar to like the NVIDIA CUDA. So with MPS, so it's easy to run. It's like really cool to run like things faster on Mac also to train things on like the bare metal. So you can also utilize that as much as possible. Yes, but I don't know if but people have like said about like the efficiency. There are like some praise about like the Mac MPS, but still like mostly for
Yeah, it's
really
still at
high.
the early
Yeah.
stage, but
Yes.
much like the way you put like a CPU, you put MPS as well. It
Yes.
works the same way. So,
Yeah.
but also for the Mac is the not the old Intel version, the
Mm.
Apple Silicon versions. So,
Yeah.
yeah.
Mm. Okay. Thank you, Doctor. Yeah. And yes, so yeah, I think we're a bit slightly so so most of these things we explain them, which is the shape and data type and device. So I'll just skip a bit of this. Then I think briefly we just talk about manipulating tensors. So when you have these tensors, so at the end of the day, you want to perform some kind of operations in them. So some of the operations it's like addition, subtraction, multiplication, and just how you have in your Python, you can easily create these operations in them. And you could have addition, you can like multiply the tensor by some value. You can see we've created a tensor of 1, 2, 3, and you can add them and you can see the value changes here effectively. And here you can also see like the value changes as you multiply them in space. So I would quickly like skip a bit of this since these are like things you are familiar with or you will be familiar with and go to, because of time, and go to much more complex things. So at the end of the day, like when you deal with like deep learning, so one thing that you will not be able to escape is matrix multiplication, because this is very key. So most operations in deep learning or machine learning, when you use PyTorch, happens within matrices where you have like several matrices interacting with one another. Remember how we said like you can represent the data as a matrix and internal operations of your model as a matrix? Don't worry, I will still come over this. So when you deal with machine learning models, you have to do several matrix operations. So, which is like very, very key. So what happens in matrix operation is, if you are familiar, it's like where you have matrix of different shapes. For instance, let's see this matrix here. So here you have matrix of shape 2 by 3 and 3 by 2. So what you always need to be mindful of, the inner dimensions of the matrix must match just so that it could multiply to each other with each other. So here where you have 3 by 2 and you try to multiply it by 2 by 3 multiplied by 2 by 3, at the end of the day, the result would be 2 by 2. So this is just like one operation of matrix, but at the end of the day, when dealing with deep learning, you do like several large scale matrix multiplication, but understanding at a very small scale, it's like really good and nice. So we won't go into like the theory of matrix operation. So if you're not familiar with matrix operation, maybe it might be good, maybe after the class, just revise a bit of it, but it's not like a required knowledge, just for you to have like some kind of understanding on it. So what we can do is, okay, yes. So you don't need to learn like matrix multiplication by scratch. So you have PyTorch. So that's the importance of PyTorch. So it will do all the work you need for you at the end of the day. So let's look at like one matrix operation, which is like this. So let's say we've defined a tensor of 1, 2, 3. So easily you can do element by element operation. So what it's telling you element by element is like a matrix, you have two matrices like 1, 2, 3. And let's say you want to multiply them together. So each element will multiply each element, and at the end of the day, you have 1, 4, 9. So you can see the first element here is interacting with this. This element is interacting with this. This is this. So that's like element to element operation. But you don't need to worry about that like in a handwritten way as I did here. So you have like PyTorch. So just pass it to PyTorch. It will handle everything for you. You don't need to worry about anything. So yes. And yes, so if you want to do like much more bigger matrix operation, which is not element by element, so what you might want to do is like call this API, which is like matmult. So it's like basically short for matrix operation. So any two tensors, then you can easily multiply them for you. And yes. Okay, I think I will just go over this. Don't worry, when you experiment with the notebooks, you come to see how it works and see it, but feel free to ask any. I'm always active on Discord, so ask your questions there and I'll be very happy to answer you. So as we said, the inner dimensions of the tensors should match. So as you can see here, this matrix has like shape 3 by 2 and 3 by 2 here. So, and what we usually want for matrix is like if you understand like the actual theory, like the inner dimension won't match. If it doesn't match, you can't do it theoretically, and even in PyTorch it raises an error, which happens here, as you will see. So it will like shout that shapes do not match. It's 3 by 2 and 3 by 3. So once it tells you this shape does not match, so it's easy. You can just go into your code and see what's happening, what's wrong, and easily like try to rectify it at the end of the day. So for the sake of time, I will briefly like go over one topic because largely I think there's some visualization in which you will see, and largely there's like really good explanations on this. So I believe like most of our time we went really deep into some concepts, and I think which is very cool for you also to understand. So perhaps going forward, we'll try to see how we will maximize the time at the end of the day. And let me just go over the GPU section. So these are things I believe you can do. So, but if there are any challenges, happy to like have an extra session. I know this material can be quite dense to cover in 1 hour. So let me see. Yeah, so I'll just cover like briefly like running things on GPU, and just so that you understand how maybe GPU works. And if by any chance you might still need clarification, so maybe in the next lecture we can still go over this. I know like this is one of the like longest part of the or longest material of this particular like session. So don't worry for the subsequent one to be like much better in terms of like the delivery. So traditionally, like when you try to run things, you try to run them on CPU, and CPU mostly are like kind of sequential in nature. So it's hard to like parallelize stacks. So what you might want or what you might need is to run things on GPU. But it's not like easily, it's accessible, but it's like expensive to get. And like any computer that has GPU has like higher price. So, but here you have them like free on Colab, so you are free to use them. And if you have Mac, so luckily, if it's a more recent version of Mac, you have MPS, so you can also run things on MPS. So yeah, so these are like specific stuff to check your if you're using like some NVIDIA GPUs, these are like some very specific commands to check like the configurations of your GPU, but don't bother about this. So what I want to discuss more with you is how you can check whether you have like CUDA available. So you have this neat API, which is touch the CUDA available. So if you have CUDA available, it returns true. And this just like sets this device to like CUDA here at the end of the day. So what happens is for every tensor you create, you can like specify the device where it should go to. So as we run this, we can see, yes, we have CUDA, yay. And so any tensor you get to create at the end of the day, you can like send it to CUDA and like it's stored in like your CUDA memory for faster computation. So this is like another API for you to call like the count of your device, like how many GPUs you have available. And as you can see here, we have just one CUDA device available here. So yeah, this doesn't relate. So once you have created a tensor, which we've seen easily, so here we create like a vector of 1, 2, 3. And what you would see is, let me just comment this. This tensor is on CPU. You can see this where it's stored. But what you want to do is like move the tensor to GPU. This where like you have this, for any tensor, it has like an attribute or a method called to. So this to means like where in space do you want to send the tensor to. So let's say you have like tensor A, then it has this neat attribute dot to. So this dot to holds, you can pass in like the device, you can pass in like the data type, and easily what happens is any tensor it creates, it moves them to any device you want. Or if you want to change the data type, imagine initially I created a tensor of type float32 and I want it to be int16, then I pass it to this to method here and it changes what I need for me. So here you can see it's saved on CUDA. Then you have like semicolon here, and you have like 0. This is like the index of your GPU you are using. Let's say you have several GPUs. Let's say GPU. Let's say GPU. So you start indexing by 0, 1, maybe GPU 1, GPU 2. That's continuously, that's how it goes. So here it's telling you this tensor that we have, we've saved this tensor here on this device. So, and yeah, so that's about running like tensors on GPU. So hopefully you got to understand what PyTorch is, the importance of PyTorch, and what are tensors. So tensors are just containers that hold different representations of numbers for you. And in machine learning, most of the work you'll be doing is on tensors. And we looked at how you could manipulate tensors, and it's very, very similar to NumPy. So hopefully if you've worked with NumPy, so almost most of the operations are similar to NumPy with some bit of variations. So the variation doesn't exceed what we talked about on the device and like, yeah, mostly on the device. So because NumPy is mostly on what you run, NumPy is mostly on CPU. So, but with JAX, that's something external. JAX help you to run them on like CPU, GPU, and TPUs. So that's majorly it. So happy to answer your questions. Maybe we can just extend with like 10 minutes for questions at any, just feel free to ask about anything. So I will just go to, yeah, there's a question about like the notebook. So the notebook is on the main, you will get a message about like the notebook so it's on the main course page for Ariwa Data Science. So when you go to the Ariwa Data Science page, so you can easily see it there. So you have like your resources and you can see, so you can find like the resource here and you can click on it. So cool for GPUs, unfortunately, we don't give GPUs, but you can find free GPUs on Colab. So you have like free available GPUs. I guess it's for like 10 hours free for you to run continuously. Then you could experiment as much as you want on GPU. So yeah, I'll just call up if there are any questions, but if there are not, but also feel free to ask questions on the Discord. Okay, I think there's one. Yeah, this touch API. So when I say touch APIs, it's much more of like a generic term. I understand it's like if you want to go like beyond like directly, we can just easily say they are touch methods. But when I say API, it just means like the methods and also the attributes. So API is just something. So I just say API because it kind of shadows the underlying work of what you need to do. So let's say matrix multiplication. So you can just say you have like a touch API for matrix multiplication. So it can also be a method. So there's a comment on, let me see, getting kicked out of Discord. Honestly, I also have the same challenge, but we'll see how to resolve it and get back to you, Omar. Thank you so much. So then, so each of the class will,
What's
yes.
happening with Discord?
Yes, sir. Like for me, anytime I join, so after like a few minutes, like it seems I'm like kicked out of the Discord.
Oh, really?
So yes, sir. So
Okay. Maybe there is something. I will check I have a bot. Maybe I don't
yes,
know.
sir.
It is the bot that
Okay,
kick
okay.
all
Okay.
out. I will check with the bot. I don't know. I will check with the bot
Yes,
uh,
sir.
to see if there is anything wrong with that. Yeah.
Okay.
Mhm.
Okay, yes, sir. Yes, sir. Thank you very much. Then there is when next the class. Yeah, so the class is always by 8 p.m. except otherwise. Saturday 8 p.m. always except otherwise. So for the subsequent week. But if there's anything else, we'll let you know. Then the exercises. So for this exercise, you'll get an information about the exercise latest by before the end of tomorrow. So as always, what you would always need to do is, yeah, as always suggested, always check the ROA data science page. You have every information you need. So it will be updated like just immediately after this class. So you have like the recordings and you have like a link to the exercise. Everything you need about this course, every information you need is here on this page. We'll also send it on Discord and email it to you. So you have like exercise link and also like recordings of subsequent any recordings you have on this Iowa data science link. So quickly, I'll just go over like some important question about like calling dot by Naziru, which is a very nice question, calling dot items on vectors, matrix, and tensors. So dot items only work on scalar values. As we scale, scalar value is just like one numeric value. So dot item only works on scalar values. So for vectors, matrix, and tensors, you can't use dot item. So what you can do is get like the corresponding numpy array of those objects, tensor objects. So, but simply dot item only works on scalars. You can use them on vectors, matrix, or other tensors. Thank you. Nice question. Then the free 10 hours, the free 10 hours is daily. So after 10 hours, you get like it get expired. But for now, all this you don't need to worry about the 10 hours for now. Even subsequent like machine learning training, I think it should be enough. So at the end of the day, maybe one trick you might do is have like several Gmail accounts. So once your 10 hours elapses, you get another 10 hours with another Gmail. So you'll
Yeah,
be,
another option we can do is,
yes.
Mustafa, some of the people here might not be familiar with how to use collab, but I
Yes.
think what we can do is we can have separate because we have TAs that can help. So
Okay.
they can do, for example, within the week or sometime like all Saturdays, like how to use collab and Kaggle. I think
Okay.
Kaggle now is offering maybe much better and higher access to the GPU, free access.
Yeah.
So, and also Lukman, I think, has been using Kaggle. So maybe Lukman can prepare a session
Okay.
how to use these resources like Kaggle and Collab.
Mm,
So this will allow smooth learning with the participant because now if we allow them the learning curve for them to go and learn the Collab, and so if we just
mm,
introduce them in one session, not the normal session you do on Saturday, but you can
mm,
fix a date where we can have them show them how to use a Collab, how to use a Kaggle to have access
mm.
to the GPU.
Okay. Okay. Nice. Thank you very much, sir. I think nice one. Yeah, I will interact with Lukman about this. Thank you very much. Then there is a question from Ibrahim. So when working with images, computer vision, which library is more robust, PyTorch or TensorFlow? Yes, I can tell you which is better. So right now we are working with PyTorch because it's like much more widely used. So, and has very wide like developer community. So any error you get, it's easy to like debug. So, but unlike TensorFlow is still like also being used, but I can't say which is much more robust, but most
Yeah.
industry and top tech companies, yes.
Yeah, for research now, PyTorch is
Mm,
the gold to standard.
mm,
If you want to get like a quick fix if you have issue, or
mm,
support. And also, like if you see research papers, like out of 100, maybe you see
mm,
50 have been
yeah,
implemented with PyTorch.
mm,
90%. So it's easy for you to adapt PyTorch. So,
mm,
yeah, TensorFlow is okay, but in research community now, the
mm,
PyTorch is way forward. Yeah.
yeah. I think so even in industry, because even like Meta and
Yeah.
most of top
Yeah.
companies, they just use
PyTorch,
PyTorch.
yeah, of
So
course, like PyTorch
uh,
come from Meta, so they are the ones.
uh,
So, yeah.
uh,
Yeah,
yes, sir.
Python I think is the yeah, but like at some point people start doing the TensorFlow is easy and other stuff, but
Mm,
if you really want to go far, just
mm,
learn the PyTorch and yeah.
mm, mm. Okay, okay. Yeah, thank you very much. Yeah, so there is some comment by Abdullah here about like joining. So I guess so yeah, so for the if you are not registered for the class officially, you can always like join via the link sent or watch the YouTube videos. You're always free about to join. So there's a question about like frequency of the class. I would say that like the class will be always weekly. So this is always weekly. So additional classes will be like more of like just classes to help you like get some extra skills you might need. So like the one doctor talked about like for collab and any other classes, or maybe you have challenges with the exercises, so you can create some problem solving questions for you at the end of the day. So yeah, so those are like majorly the questions. But if I missed anything, always feel free to message on Discord. So we are always there and very happy to help any point in time. So I really hope like the class was beneficial to you. And if anything, just feel free, or any confusing points, you can message on Discord or in the subsequent class. Happy to go over it and see how it goes. So happy, yeah, glad you guys were here. I hope you have you let me see. You enjoy the rest of your weekend. Yeah, thank you very much. Yes, you're welcome. Bye.